Welcome. Today, we're going to break down how to add and subtract polynomials. This is a really foundational skill you're going to use all the time in algebra. By the end of this, you'll be able to tackle these expressions with a whole lot of confidence. So here's our game plan. We'll kick things off with the basic definitions, then cover the single most important rule you need to know. After that, we'll apply it to both adding and subtracting, and we'll wrap up with a quick checklist to help you make sure you get it right every single time.
Okay, first things first, let's really understand what these expressions are and get comfortable with the words we're going to be using.
So polynomials are built from these individual pieces we call terms. A term can be super simple, like just a number, 15. Or it could be a variable, like x. Or it can be a mix of numbers and variables all multiplied together, like 8d squared. Now, when we take these individual terms and start connecting them with plus or minus signs, we've officially created a polynomial. You might know the prefix poly just means many, so a polynomial is really just an expression with many terms. And as you can see here, they come in different shapes and sizes. A polynomial can be just one single term, like the x squared you see on the left. We actually have a special name for that, a monomial, because mono means one. Or it can be a more complex expression with a bunch of terms like the one on the right. Okay, one last piece of vocab for now, the degree. This is really simple. It just tells us the highest power or the biggest exponent that you see in the entire expression. It's just a quick way to help us classify what kind of polynomial we're looking at. All right, now for what I think is the most important concept today. This one single rule is behind everything we're about to do with adding and subtracting, and it is you can only combine like terms. Well, that leads to a pretty obvious question, right? What in the world does it mean for two terms to be like each other? Think about it like sorting laundry. You put all the socks in one pile and all the shirts in another. It's the same idea here. On the left, you see terms that belong together. 7x squared and 2x squared are both x squareds. 14y and 8y are both y's. On the right, though, they're different. An x squared isn't the same as an x. A y isn't the same as a y squared. So here's the official recipe. For terms to be like, they have to check two boxes. First, they absolutely must have the same variables. And second, those variables must have the exact same exponents. The numbers out front, what we call the coefficients, they can be different. That's totally fine. All right, let's take that golden rule and put it into practice. We'll start with our first operation, adding entire polynomials together. It's really all about staying organized and then combining those like terms we just talked about. We're going to walk through this example step by step. So here we're adding two polynomials, and each one happens to have three terms. You know, the number one key to avoiding simple mistakes in algebra is just keeping your work neat and organized. And for adding and subtracting polynomials, the vertical method is an absolutely fantastic tool for doing just that. So here's how it works. We rewrite the problem, but we stack the polynomials on top of each other, making sure to line up the like terms in perfect columns. See? The y squareds are together, the y's are together, and the plain numbers are together. Now it's just simple addition. 14 plus 3 is 17, so we have 17y squared. 6 plus 8 is 14, so that's 14y. And negative 4 plus 5 is a positive 1. Okay, let's switch gears and dive into subtraction. Now, this uses the exact same core idea of combining like terms, but, and this is a big but, there is one very, very important extra step that you cannot forget. I want to pause for a second and point out the single most common mistake students make when they're learning this. If you can get this one thing right, you're going to save yourself a lot of headaches. And here it is. It's all about that negative sign. It's so easy to forget that the subtraction sign in front of a parentheses has to apply to every single term inside of it, not just the very first one. So let's model this with a fresh example that really shows what's going on. We're taking that first polynomial and subtracting the second one from it. The process is always the same, and it's super reliable. Step 1, you deal with that negative sign by distributing it through the second polynomial. Once you do that, the problem basically turns into an addition problem, just like the ones we were doing a minute ago. See what happened here? That subtraction sign went through and flipped the sign of every single term. The positive 6a became a negative 6a. The positive 24b became negative 24b, and the positive 3c became negative 3c.
Now it's just an addition problem.
So with that negative sign taken care of, we can go right back to our trusty vertical method. We line up our like terms. Okay, 8a plus a negative 6a gives us 2a. Then 24b plus a negative 24b, well, that just cancels out to 0. And finally, negative 12c plus a negative 3c gives us negative 15c. So after we correctly distributed that negative and combined all our like terms, we are left with our final, much simpler answer, 2a minus 15c. All right, to wrap all of this up, I want to give you a simple checklist. If you can just run through these questions in your head after every problem, you'll catch any little mistakes before they become a big deal. Just ask yourself these 3 quick things. Number 1, if I was subtracting, did I remember to distribute that negative to every term? Number 2, did I only combine terms that were truly alike, same variable, same exponent? And finally, number 3, did I do the basic adding and subtracting right at the end? Using this little checklist will help you build so much accuracy and confidence.